Hey there, you young whippersnapper. Get off my lawn. And get ready to do some funky absolute value inequalities. Now listen, I don't want to waste your time. We've just established I'm an old man. I don't have much time left to waste. So let's get right into it. With every new type of equation and inequality that we've learned how to solve thus far, a common thread that we've discovered is that we've always got to be on the lookout for those quote-unquote funky cases, where our solution sets don't behave the way we expect them to. For inequalities with absolute value, thankfully, we've only got two funky cases to keep on our radar. The first one might show up in a problem like this. 10 minus 5 times the absolute value of 2x minus 1 is less than 20. So in the back of your mind, I want you to be thinking about what's funky, what's weird, what's different, what's new, how is this going to change from the types of inequalities containing absolute value we've seen up until this point. But you should hopefully have a pretty good idea, at least of the first couple steps you might take to get towards your goal of solving for your variable. So give yourself a minute timer, see how far you get. Have fun, play around. Alrighty, that's too much fun for old man Mr. Villel. I'm here to break up your party. So, 10 minus 5 times the absolute value. Well, my goal, if I'm trying to solve an absolute value thing, I usually want to begin by getting absolute value by itself. So I've got a 10 and a negative 5 connected to the absolute value. In this case, reverse order of operations, much easier for us to get rid of that 10 first. So subtracting 10, right? That leaves me with negative 5 times the absolute value of 2x minus 1 is less than 10. And then I'll divide both sides by negative 5. Alarm bells, alarm bells, alarm bells, alarm bells. If I divide by a negative, what needs to happen? 5, 4, 3, 2, 1. Well, whenever I multiply or divide an inequality by a negative, I need to flip my inequality. So I'm going to take my less than symbol. It's going to swap to a greater than symbol. Right on the left side, I divided by negative 5, so I'm just left with the 2x minus 1 in my absolute value bars is going to be now greater than negative 2. Okay, what's funky? What's weird? What's new? What's different? Well, I'm saying the absolute value is greater than negative 2. All of the problems we saw yesterday had positive numbers on the other side. So now I need to find a way to make sense of this. Take 30 seconds, take a risk, take a chance. What do you know about absolute value, and how can you use that to make sense of what this inequality is telling us? Take 30 seconds, see what you come up with. No right answers. There's kind of a right answer, but who cares? What do you think? Go. Alrighty, well, I'm going to hope you put that beautiful brain to use. Let's see. So, knowing what we know about absolute value, the most important thing that we've learned about absolute value, this fact about it that we keep coming back to, is that absolute value is always what kind of number? Well, it's always, if I take the absolute value of a number, positive. So absolute value is always going to be a positive value. So looking at this inequality, that's telling me the left side here is always going to be a positive value. But what I'm saying then is that the left side is positive, and then it's greater than a negative number on the right side. But if absolute value is always positive, and the right side here is a negative number, what that tells us is that the left side is in fact always going to be greater than a negative number, right? A positive number will always be greater than a negative number. So what this is saying is that the inequality that I've written, because absolute value is always positive and a positive number is always bigger than a negative, this is by default a true statement. This is always true. And when I come up with a statement that is always true, what does that tell me about my equation or my inequality? 5, 4, 3, 2, 1. This has all real numbers as its solution set. Cool. This is a statement that's always true. It's fundamentally true. All real numbers, right, or my funky bold R is my solution set. Cool. So this is an all real numbers case. What do you think is going to come next? Well, let's see. The absolute value of 3m minus 5 is less than negative 8. So the same idea here, right? I've set us up nicely. We don't have to do anything to get the absolute value by itself. What do you know about absolute value? What is this statement saying to you, and how can you use it to make sense of the solution set of this inequality? Take 30 seconds, pause the video, take a risk, take a chance, who cares? What do you think? Okay, once again, I know that absolute value, in other words, the left side of this inequality, this is a positive number. And I've got a negative number on the right side. So I've got something positive on the left. I'm saying that's less than a negative number. Well, that don't make no kind of sense. So what I'm saying here, I know that absolute value, it's a positive number. Absolute value can never be less than a negative number. So if absolute value can never be less than a negative number, this statement is fundamentally false. There's no way the left side could ever be less than the right side. This inequality has no solution, right? Anytime that we've arrived at a statement that is always false, we say that it has no solution, right? And we can use our empty set as a shorthand. In other words, let's say I want to generalize. If I encounter an absolute value that is greater than a negative number, or an absolute value, right, that is greater than, I could also be or equal to a negative number. What does that tell me? Same thing if I encounter an absolute value that is less than or equal to a negative number. Say that that negative number is negative a. If the absolute value is greater than or equal to the negative, what does that tell you about the solution set? If it's less than or equal to the negative, what does that tell you about the solution set? Take 30 seconds, pause the video. What do you think? Go. Alrighty, well, if I take an absolute value must be positive. In our first bullet point here, I'm saying a positive number is greater than a negative number, or greater than or equal to a negative number. Both of these are fundamentally true. This is an all real numbers case. But if I say that the absolute value is less than a negative or less than or equal to a negative, that can't be true. A positive can never be less than a negative. So these will both give me some no solutions cases. Magnificent. With this idea in mind, let's do 2 quick practice problems, and then you're free. Let's solve. Let's graph. Let's write our notations. Give yourselves a 2-minute timer for each problem. Again, your goal is to get the absolute value by itself. Once you're there, you're going to figure out, is it a split? Is it a sandwich? Is it an all real numbers? Or is it a no solution? Go, go, go. Have fun. Are you ready? Are you ready? Are you ready? I'm ready. So, let's take the one on the left. 2 times the absolute value of 3 minus 3d minus 10 is less than 0. My goal to begin with is to get the absolute value by itself. So my opening move, let's start by adding 10 to both sides. Plus 10, plus 10. I've got 2 times the absolute value of 3 minus 3d is less than 10. Divide both sides by 2. On the left side, they undo each other. And I've got the absolute value of 3 minus 3d is less than 5. Cool. From here, I don't have a negative number on the other side, so this is not a funky case. Here I'm saying the absolute value is less than 5. So here, think of it like a question. What question am I going to ask myself to make sense of this? Okay, well, hopefully you remember from last time. If I have a less than symbol, I want to know, does my absolute value need to be closer to 0 than 5 or farther from 0 than 5? Well, if the absolute value is less than 5, I'm getting closer to 0. I need to be on the inside of the 5 and the negative 5. This is going to be a sandwich. So what that tells me here is that 3 minus 3d, if its absolute value is less than 5, it needs to be something less than 5 and greater than negative 5. And now all I've got to do is get that d by itself. Well, let's minus 3 to begin. When I minus 3 from the middle, I minus 3 from all parts. Negative 5 minus 3 is negative 8, which is less than negative 3d, which is less than 2. Last move, we'll divide all 3 of our parts by negative 3. I divided by negative 3, so I need to flip my inequalities. So this is going to become 2 greater than symbols. In the middle, right, my negative 3's went away. I'm left just with d here. Negative 8 divided by negative 3. Negative divided by a negative would be positive 8/3. 2 divided by negative 3 would be negative 2/3. Cool. On my number line, I'm going to place my two numbers. Negative 2/3 is going to go to the left. 8/3 is going to go to the right. In this case, both of them have a greater than symbol, no or equal to, so this is a open circle. And we've said this is going to be a sandwich, so I'm going to color in the part of my number line in between these two values. For my set builder notation and my interval notation, again for set builder, right, I can't get away with my shorthand here because I've shaded in parts of my number line. So I'm going to say that I want values of d such that I can take my 8/3 is greater than d is greater than negative 2/3. If you'd rather, you can write it the other order. Negative 2/3 is less than d, which is less than 8/3. Who cares? Doesn't really matter. Interval notation. Reading the part of the number line that I shaded in, I started on the left at negative 2/3. I kept going on the right until I hit 8/3. Both of these have open circles, so both of them get parentheses. Nice. For our 1 on the right, I've got 1 plus the absolute value of 7d plus 2 all over negative 3 is less than or equal to 3. So here, again, my goal is to get the absolute value by itself. Start by subtracting 1 from both sides. That leaves me with the absolute value of 7d plus 2 over negative 3 is less than or equal to, 2. And here, now I've got division by negative 3. Let's multiply both sides by negative 3 to undo it. On the left side, these go away. I've got my absolute value is going to be, again, I multiplied by a negative number, so I'm going to flip my inequality. This is going to become greater than or equal to negative 6. And again, I'm in a funky case. Why do I know I'm in a funky case? 5, 4, 3, 2, 1. Well, I see a negative on the other side. Whenever I see a negative number on the other side, I know I've got an issue that I've got to unissue. Well, here, I'm saying that the absolute value has to be greater than or equal to negative 6. Absolute value is always a positive number. So a positive number on the left will always be greater than or equal to the negative number on the right. This statement is always true. All real numbers is my solution set. The graph of all real numbers, again, I take my number line, I can label it with my variable if I want to, but it's everything, right? All real numbers means any number works. I could take anything on the number line, so I'll shade in my whole number line. My set builder notation for all real numbers, again, is just my all real numbers symbol. And my interval notation, well, reading the part of the number line that I colored in, I started all the way on the left, right? So that's at negative infinity. I ended all the way on the right, so that's at positive infinity. Infinities aren't numbers, so both of them get parentheses. Alrighty, my loves, you did it. You made it. You've talked about some absolute value inequalities in their entirety. I will see you when I see you. Take care, be well, and get out of my classroom.